Welcome to episode number 9 of Blueprint, our video blog for responsible manufacturing. My name is Björn and I'm heading the sustainability department at EOS. We're here for this episode at a very special location. We're at Rapid Plus TCT in Los Angeles, California. And that gives us the great opportunity to meet Brian Neff. CEO of Sintavia, which is an aviation component manufacturing company based in Florida. And Brian is also the founder of the Additive Manufacturer Green Trade Association. And in this episode, you will learn why additive is so important for aviation with regards to sustainability, environmental sustainability, how customers can benefit from that, why data is so important, and what this has to do with global collaboration. So, welcome, Brian.
Thank you very much, Björn.
Thank you very much for joining us. We're really glad to have you. Before we start into the conversation, may I please ask to introduce yourself shortly?
Of course. Thank you very much for having me here. I'm Brian Neff. I'm the founder and CEO of a company called Sintavia. I was also the founder and current chair of the Additive Manufacturer Green Trade Association. And I think the first thing I always tell people about myself is I'm not an additive person. My background is in particularly commercial aviation. I'm actually a third generation aviation professional. My grandfather was the VP of maintenance at an airline called TWA, and my dad worked at about 6 different airlines before he founded not one but 2 cargo airlines. And the first one was called Southern Air, and that's where I started my business and my career as the finance VP, then CFO, then president. And then I moved on to a jet engine MRO, which is a repair shop called CTS Engines. And that was really the genesis for how I came up with the idea of Sintavia. And what Sintavia is an aerospace component OEM. So we design and additively manufacture complex mechanical parts and components and systems for aerospace and defense applications, particularly thermodynamic components like heat exchangers, propulsion systems that have impellers and combustors in them. But basically the common theme to all of the parts that we design and manufacture is that they are traditionally very difficult to manufacture with a very limited supply chain. And additive presents an opportunity to build I wouldn't say just a better part, but a more optimized part. You know, as you know very well, Björn, taking a component from a computer screen and turning it into reality, that's easier said than done, and it can only be done in an additive format. And the thing about Sintavia that is really a differentiator to us and for us is we have an end-to-end capability. So from the design of the component and simulation of the performance of the component, through the additive design, through the manufacturing plan, through the printing, post-processing, furnacing, and final certification, we do all of that under one roof. And I think that allows us to have a pretty unique viewpoint of just the aerospace component industry and the way additive is applied in that industry. Because when you make a mistake in the process, which you often do and sometimes do, it's easy to course correct. And having the ability to do everything under one roof means that if something goes wrong, at this point, we can just go back a little bit and restart it and fix it. I think that we were founded in 2015. We have about 105 employees, more than half of whom are degreed engineers, which is fun to run a company that has a lot of engineers, as you can probably appreciate. We're happy to be a part of the EOS family. We have 23 medium and large printers. Of those, 17 of them are EOS printers.
Thank you very much. That's really an incredible story, actually, and we're really proud to have you here and sharing your expertise with us. So thank you for that introduction. In a TED Talk, you said that the aviation industry needs to go ahead of the game in terms of additive and environmental benefits. Can you share a bit more what you meant by that?
Well, I think that if you look at greenhouse gas emissions by industry, commercial aviation is fairly small. I mean, it's maybe 5%, maybe a little less of global emissions come from this one industry. But the one thing the aviation industry has is a common touch point that all of us experience, going to the airport, going on an aircraft, dealing with lines, et cetera. And so everybody understands that aviation exists. It's a big industry, and it's driven completely by Jet A fuel. And I think that is why the commercial aviation industry does have an imaging problem. It has an optics problem, because it has a clientele that wants it to find better solutions for reducing emissions. And I think for the most part in the U.S. and certainly in Europe, there's been a lot of good focus on sustainable jet fuel. And also the electrification of commercial flight. And additive certainly has a big role to play in that. And so when I started thinking about using the environmental benefits of additive within aerospace, I said this is a terrific opportunity, because you can work on not just the lightweighting, which is what I talked about in my TED Talk, which has a huge impact downstream over a 25-year life of an aircraft. But you can also work on better propulsion systems, electrical propulsion systems. You can also work on manufacturing using additive, just the traditional parts that are part of your sustainment efforts. So I think that additive in aerospace, there's a natural sustainability fit. And I think that everybody kind of gets that at the high levels of these airlines. I think everybody gets it at the airframers and the engine manufacturers. And so I really do expect to see a lot more use of additive in the front end design, but also in some of the replacement sustainment aspects that are out there.
Okay. Do you have any other examples? I mean, what do you do?
Well, I think that we focused a lot on the manufacturing process itself as being a more sustainable way to produce parts, even if those parts haven't been lightweighted or they aren't part of a new generation of electrified flight. One of the reasons why we founded the AMGTA was that we really wanted to understand the manufacturing process and the energy inputs and the energy outputs and the waste streams that come out of that process. We sort of anecdotally knew that additive was a more efficient form of manufacturing, but we couldn't go to our customers and say, hey, we can build you a better part, we can do it faster, and we can do it on a steady state unit cost that's going to be lower. Oh, and by the way, it's more efficient and more sustainable. We really wanted to figure out a way to quantify that. And I think that when you look at a lot of the stuff right now in aviation is kind of a like-for-like substitution because they can't get parts. The supply chain is pretty bad right now, I think, across a lot of industries, and aerospace is no exception. But when you're producing those parts, even if it's the same 40-year-old component, we focus on the fact that it's a better way to do that. So I think that even if you don't get the design impact quite as much on an old part, you're still getting the benefits of the technology in a better format in the way that you're making that part.
Yeah, so that's interesting, and I think sometimes it's really challenging to convince someone to make additional efforts to, for example, redesign components or change something in the supply chain for environmental gains. So what are your experiences there with your customers, or is it more maybe the economic benefit that is maybe the first argument for them?
I mean, I think that it's really comes down to part need and where in the world of aerospace and defense. So one of the reasons why, if you look at the different industries that have adopted additive, aerospace is probably in the lead or tied with implants or medical as medical devices as just an extreme adoption or extreme adopter, early adopter of it. One of the reasons why is that the parts aren't super big that we manufacture, but they are highly engineered and they're very expensive. So you have parts on an engine, for example, that are the size of your fist that are $25,000. And that's because of the materials and the engineering and the manufacturing process that was used to make that. That's one of the reasons why people will make that investment in moving parts into the additive world, because they know that they need them and they're very, very expensive. So I think that at least for what we see now in the state of the industry, it is a very much a needs-based approach to parts and part families. I think maybe sadly the environmental aspect of it is secondary to that. I do think that our customers all want to move in that direction. I think they want to be good corporate citizens and have that they want to get to that point, but it's much easier for them to do that in new technology and new aircraft and new designs. Whereas for now, a lot of the stuff that they're using us for is more traditional, like for like kind of replacements.
But are you sometimes trying to inspire your customers to embrace a more
sure.
responsible way of manufacturing? And if
sure.
yes, how do you do that? Or still would there be other compelling arguments?
Yeah, so I mean, within the AMGTA, that's one of the reasons we wanted to have an organization. It's a green trade organization. Actually, I thought of it, and I was inspired to do it by a lot of things that I saw in Germany and also in Austria in terms of some of the traditional, I'd say, parts of the political spectrum that didn't really work well together, coming together to form these private, capitalist, companies and political positions that also wanted to be good stewards of the environment and of the earth, and really coming together and working really, really well. And so the idea of a green trade organization is that. I mean, we're not an environmental organization. We're not a trade organization. We want to do the best that we can using the technology in the best ways possible. And I think that we can use that and the data that we have researched and we have published, and we will continue to research and publish, to go to a Boeing and say, and I always, the bracket is something obviously it's near and dear to my heart for many years, but for every kilogram, as we demonstrated in that study that we did, for every kilogram of weight savings that you can make on an aircraft over a 20-year life, it saves something like 13 or 14,000 kilograms of carbon dioxide. So for every kilogram that you take out of an aircraft or an aircraft engine over the course of a 20 or 25-year operating life of that aircraft, you can reduce the fuel consumption, the Jet A consumption, by 13 or 14,000 kilograms. So there's just a tremendous, impact that I think that the airframers and that the public are both aware of and want. And so I think that when we go to our customers, that is definitely a major marketing point that we make. Again, we also say we can get it faster. It can come out better, and it can have a lower, steady state unit cost. But it is demonstrably a better way to build these parts.
Yeah. So you're producing a low pressure turbine bracket, and you also did a life cycle assessment, an LCA on that recently. Can you tell us a bit more about the setup of this analysis?
Sure.
So what is important if you're doing an LCA? How did you do it?
Yeah. So the genesis for Sintavia came from my last company, which was called CTS Engines, which was a jet engine repair shop. And I was introduced actually to EOS through MTU, which was a competitor to CTS, and I was touring their facility outside of Munich, and I saw some EOS M270 printers there in the second floor room, and that was really when I got inspired to build Sintavia. But it came from very much an aerospace and engine repair background. So when I'm in CTS, which we had a big facility in Fort Lauderdale, I would walk around these engines, these CF680 engines, which are on the 767s and the early model 747s, and I would look and I would say, what can we do better on this engine? What's we don't want to start with something that is going to be like safety critical or flight critical. We want something that's static. We want something that has a lot of backup, that if it fails, that it's not that big of a deal. And lo and behold, on the back of the engine, there's something called a low pressure turbine, and around the low pressure turbine there is a fuel manifold, and the fuel manifold is meant to take heat out of the low pressure turbine. And the fuel manifold is attached with 12 different of these little brackets. And we're just looking at the bracket. And I don't think in the history of jet engine repair these brackets have ever failed or anybody's ever not needed them. So, but they were the perfect candidate because they were small and they were blocky, and we thought we could do a finite element analysis on these. We could come up with a better way to build it. We could print it. We could test it, and we could use that results, and publish that and go out and talk to our customers. And so that's what we did. And so that was always just kind of like a what if. So it really was a design of experiment and just a way for us to take a look at that as a process, a lightweighting process.
Is that also kind of is that the key success criteria, what you just mentioned, to not first look at the most critical part, the safety part, but look at something, maybe you could even say boring, yeah, but with a great potential
Yeah.
for additive. I mean, do you have to have that view, right? So that is your experience, I guess, in this industry, to scan what can we do here. Is that the success factor?
Yeah, I think that you have to start with something simple and easy with your customers. I mean, you have the FAA, you have the U.S. government that are not big risk takers. They don't really like to do new things. I mean, one of the reasons I always laugh about aluminum, silicon, tin, magnesium as still the most ubiquitous kind of aluminum alloy in laser powder bed fusion, it's just because everybody knows it and we have the data that supports it. It's not the best for sure, but it's what we have and people agree to that. And I think the same thought process is there for the choice of parts. You want to start with a customer, getting them comfortable with a fairly mundane, simple part. And then move into these more complex, potentially critical safety item parts. We were actually designing and building a critical safety item heat exchanger right now, which is a very, very difficult. I would say, without question, it is the most complex aerospace component that anyone has ever designed and built via additive, and that is. I would put that up against anybody, and it's a critical safety item. So you have to test it to 4 life cycles. So you have to simulate it and test it and show that it can last on wing for whatever it is, 80,000 flight hours or something. So it's an incredible challenge for us. But additive is up for it, and that's the great thing about it. We know it's a durable, stable, good process to use. But starting with the more mundane parts and then moving into the complex parts is a really good path with these customers.
Yeah, okay. Now, after you explained how you did the LCA, what are the results? What are the key results? You shared a little bit already, but what was your key result?
I think the most interesting thing we found was that we could not only reduce weight in the component. I would say there was probably 2 big surprises. The first one is we knew we can reduce weight. No problem. We know we can take weight out of it. You can just look at the traditional bracket, and you can see it's not optimized. It's bulky, it's big right angles everywhere. So we knew we could take weight out. But the 2 surprises was number 1, the impact of that weight downstream on the aircraft. Aircraft fly 20, 25 years on average, and over the course of a 20-year or 25-year life cycle, 1 kilogram of weight savings results in something like 13,500 kilograms of fuel that you don't have to burn. I mean, it's a crazy, crazy impact. And if you just think about the takeoffs and the landings, just reducing a little bit has a bigger impact. So that was really the first surprise that we saw with that. And the second one was that it came when we started doing destructive testing on the components. We started looking to see how this component would fail and how it would compare to the traditional component and how that would fail. And what we found was it was kind of mind-blowing, is that if you really do a really good job on your simulation and how you're using FEA analyses to build a component, you can build a stronger component. You don't need to put it in it, and it's somewhat obvious. You're putting strength and weight and material where you need it, and you're taking material out from where you don't need it. So when we tested it, it was 25% more durable than the traditional version, and lighter weight, and that to us was kind of mind blowing, because you're sort of expecting there to be, at best, similar kind of performance. So you're taking weight out of a system, but that wasn't the case at all, and so that was really, really surprising.
So really interesting results, and were you also able to put anything from theory into practice already at your company, from what you've learned from this LCA?
Well, I think from a generalized standpoint, yes. I think that the way that we have been able to work with our customers to design less linear components has been sort of the first step. So people are kind of used to seeing things, vertically, and things in 90 degrees. And if you look at a traditional heat exchanger, a traditional shell and tube heat exchanger, it looks like a bunch of straws. So if you go to the fast food restaurant, there's a straw container and you just pick them up, and that's how the inside of a traditional heat exchanger looks. But heat is not a linear phenomenon. Heat radiates in 3 dimensions. So building a core that is more organic, that is a TPMS type structure, that is gyroidal in nature, I think is a big first step in convincing the customer that, hey, this is going to work. This is very, very sturdy. It may not look like a bunch of straws, but it is a better performing core. I think was really important. So that was really the first step with the bracket, was really looking at, I would call it organic types of design and really needs-based design, if you will.
In our last episode, we had Sherry Monroe as our guest, Executive Director of the Additive Manufacturer Green Trade Association. As we heard, you're the founder of that. Can you share a bit more? What was your idea? What was really the driving force behind that, to do that? Because I mean, it is something in addition to your, I guess, full calendar and agenda you already have, right? Yes. So what was the reason why you thought, okay, this is what we need?
Well, it's really twofold. The first, as I mentioned, having a single point of data and research that could be used to market, to customers and to spread and increase the adoption rate of the technology. And I thought it was really important to have that, not a clearinghouse, but have it as a single point that people can turn to and create really a network and a connection for all like-minded people within the industry to really turn to and to meet and to share ideas. And that's where the second point was, I'm just one guy and I know aerospace and I know a little bit about the laser powder bed fusion AM, but there's a lot more out there. Other kinds of modalities for metal AM and of course polymer, and now we have a guy in our organization who's doing it with concrete, which I know is a very interesting application. And I think that put all together, it's been a very successful 5 years, almost 5 years old. We had to live through COVID right when we founded the organization. But it's been, we think we have 60 members now, and we had our summit 2 days ago, which was a big success. We had almost 100 people there, which was great. And I think that we're just sort of getting started. We're just getting started on getting the word out, trying to connect good ideas with the right users in terms of what additive technologies to use for what components, and really sharing those ideas together.
From your perspective, what are the benefits for the members of AMGTA, but also maybe for the industry as such? And is there anything that has changed since you founded it?
Yeah, I think there's probably three really good benefits. The first is you have access as a member to all of our research. We publicize the high points, some of the percentages and whatnot, but the methodologies, details about what how we conducted these LCAs. It's not just LCAs. There's some business studies in there. There's some analyses of raw material, for example, and you have access to all that data. So that's something that's a big benefit because you wouldn't otherwise. Second, and probably most importantly, you have access to a wonderful network of like-minded people. Every major corporation has a sustainability group, even smaller ones, and you don't always know, looking from the outside, who that person is for, a Ford Motor Company, but we do, and we can connect you with her, for example. And as a group of people who are trying to enact positive changes across corporations, across these big companies, it's very valuable to have a place where you can network and you could trade good ideas and you can develop strategies that work commonly. So that's the second one. Then the last one is you can help guide the research and the thinking of how we are adopting this new technology across multiple industries. And so you can actually play an active role in the kind of research that we're doing, how we are looking at, again, waste streams, how we're looking at EH&S, employee health and safety. That a lot of that stuff falls into this great organization. And so, I'm a big believer in it, and I think that the folks that are members are very happy with the way we've grown. And to your second question is how we've changed. I think we've matured a great deal. When we started out, everybody said, "Okay, that's a great idea," and then what? And now at this point, I think that we have some momentum. We have some tailwinds that are pushing us, propelling us forward. We're branching out from just doing what I know, which is aviation and laser powder bed fusion, and looking at different other types of modalities for metal AM, and also from a polymer standpoint, and even concrete and other types of media. And I think that is I think the maturity of the organization has been the biggest change. And I think Sherry has done a great job as the executive director, and she's got great energy, and she's really helping to push this forward. And there's a lot of good things to come.
Mm-hmm. What do you think about the perception in the industry of AMGTA? I mean, has anything changed since you founded it?
Well, I think that sustainability has fallen out of favor a little bit. I think that maybe some of the there was kind of a big push right in 2021, 2022 even, and then with the zero interest rate world sort of going away, I think a lot of the money that was coming into particularly startups that focused on sustainability kind of pulled back a little bit. So I think that there's been a we've had some headwinds. We've had a little bit of difficulty with in some cases, but the folks that we have, again, we have a record number of members, and I think the word is out, and people appreciate what we're doing. And so I think that there's a lot of stuff out there. And what we tried to stress too is sustainability shouldn't be and isn't a political message. There's people that want to politicize it, but sustainability is the same thing as efficiency and resource efficiency. It's the same, different sides of the same coin. And if you're doing something more efficiently, you're saving money, and you're also likely being sustainable, although you have to be a little bit careful about that. So I think that looking at it as a whole, I'm extremely pleased with the progress that we've made. I think Sherry, as the executive director, has done a terrific job. I think companies like yours and the leadership that you've taken within the machine OEMs has been really, really so valuable. And what we've tried to do now is spread out into the true end users. So as I mentioned, we have Target, the big retailer here, is one of our members. We have John Deere, which is a tractor company, is a member. There's a lot of sort of end users that are looking Trane Technologies, which makes air conditioning units. Companies that want to figure out how to adopt the technology are really starting to look to the AMGTA to get some of those ideas, which is really, really rewarding for us.
I really like what you just said, to take out a bit the emotions out of the topic, and just look at it from a rational perspective, and say, okay, it makes sense. There's a reason why we do it, and so I really like that that viewpoint on it. It's
I think so. I mean, the problem is, I think there are things that are more political within that sphere, and this shouldn't be one of them. I mean, it should almost be its own world. Everybody, I mean, it's very human. It's probably the most human emotion to want to improve yourself and improve, the lot of your family and those around you and your community. Everybody should want that, and sustainability is that's really all sustainability is wanting to do things better. And I think AMGTA, in giving direction to what is better, saying this, not that, that, not this, I think is very valuable. I hope it's very valuable. It's valuable to us. And so,
I totally agree. So that's why we're a member as well.
Thank you.
We see a lot of value in that. Coming to the last question, what is your personal vision of additive manufacturing within, let's say, the next 5 years?
Well, I think that, it's funny, when you look into the future, nothing seems to happen as fast as you want it to. But then when you look in the past, everything was very logical and it happened very quickly. And I think that's very true of where we stand with additive. I think within the last year or two, there's been a redirection. I don't even know if it's additive 1.0, 2.0, 10.0, whatever. I don't even know. I don't deal with that. To look at the end use and the part use, and to really say what are the best parts, and where are we seeing this adoption to be most accepted or more accepted. And I think that's going to continue for the next 5 years. And you're going to start seeing industries like heat exchangers really take a hard shift away from traditional manufacturing. I think we have to have a couple more success stories, which we are working on. And then knowledge sort of getting pushed out into the broader market, I think you'll start to see real interest, because heat is a waste product that nobody really wants, and it's not just for aerospace. Aerospace just happens to be where a lot of money for development is right now. But once you have those designs and the plans in place, you can port those into these other industries, and I think that's going to happen in the next 5 years. Now, more broadly speaking, I can't really speak to it. I think but specifically to aerospace, you're going to see a greater and greater buy-in. And again, it won't come quick enough for my taste, but looking backwards, 5 years from now, it'll be fast. So.
Thank you so much, Brian. Thank you for your time. Interesting conversation, interesting thoughts. We appreciate a lot that you took the time and joined us on Blueprint.
Well, thank you for having me, Björn.
Thank you. And we hope that you enjoyed this episode as much as I did. And if you enjoyed it, please leave a thumb up. And as always, if you have any questions or comments, just leave it with us, and we'll make sure to have it covered in one of the next episodes. And as always, stay responsible. And the little hummingbird I showed into the camera.
Cool. Thank you. Thank you very much.
This is the shirt with the hummingbird.
Oh, I love it. That's beautiful. Thank you very much.
We can check if that's the right size.
It's fine. It's perfect.
Yeah.